Hello, this is Old Electronics Fan, and this is part 2 of my Zenith battery AC radio, and the 6G001, I believe. Couple of things. Well, this is my completed mess here. There's a couple of things I want to point out, and I've mentioned it before, and probably being redundant, but this is part 2. So the way this radio is designed is that the ground, or B minus, on this set is insulated from the chassis. And to do that, when you're looking at this electrolytic, I'm touching an insulator plate, which is connected to the chassis through these rivets. And then hiding in the shadows over here is one of the 4 pins that go through that insulator plate and then are twisted to lock it into place. So these pins are used as ground points, or common returns, as the circuit diagram calls it. And so here's what I did. I took one of these, and since I can't just mount this to the chassis anymore because I want to use this ground, I have 4 capacitors that have to fit on here. And while I can get to that ground for one of them, which is what I did, I want the others. It would make it a whole lot nicer, neater, more easier if I could mount these 3 and have them share this common ground. So what I did was I took this terminal strip, I bent this tab down so this stuck out straight, and then, because there's 4 of these pins on this thing, so on this pin over here of this electrolytic, I soldered this pin to that ground pin of the electrolytic, which then gave me the ground I needed to attach everything and all that good stuff. Now there's something else I wanted to mention, which is really kind of bizarre to me, because I've never seen this before. I don't know, I've never seen one of these, and yet, okay, so to me, to you, this looks like a capacitor. Sometimes these things are paper, sometimes they're mica. Quite often they're the mica caps. So, not knowing which one it was, I decided I would test it. And my surprise and my shock was to find out this is not a capacitor. This is, and the circuit diagram calls it a wire-wound resistor. Now I know that I've mentioned this before, that you have to watch out for schematics. You can't fully trust them. Now the schematic calls this an 870 ohm resistor. However, when I measured it, it measured out as an 830. Now if you look at the color on this, you've got a gray, red, and a brown. That says this should be an 820. 10 ohms to me said, yeah, fine, especially since it's supposed to be a wire-wound resistor. But I've never seen one before, and I'm just wondering if anyone else has. So if you want to put down in the comments what that is, or what you know about those. This is the first time I've ever run into one. And like I said, I was rather shocked when I tried testing it and found out that it made a very lousy capacitor, but makes a great resistor. It took me some time to trace down where it was because I couldn't believe what it was. But in the schematic there is indeed an 870 ohm resistor in that location. So I came to that conclusion that yes, that's what it is. So so I went ahead and I finished the rest of this radio. And I mentioned that, I don't know if I have that handy. Okay. One of the things that I was also kind of wondering about was this guy. And it says, let's say micro or mica? I think it says mica. Yeah, mica mold. I highly doubt this is mica. I'm fairly confident this is paper. And one of the reasons why I think it's paper is because this thing leaks horrendously. And Alright. Now, on this radio, maybe I can zoom in a little bit here. Now, on this radio, because of its design, because this is designed to run on batteries as well as the line cord, everything beyond beyond this tube is DC. This is a rectifier. So the power cord connects one side here, one side here. That's the last time you see AC in this set. So what you have here, you're not going to have AC on this. This is DC right here. This is your B minus. So this capacitor isn't there to keep AC from getting to the chassis. Since I'm still relatively new to doing all this, my conclusion is that this capacitor is here to reduce noise. Because basically you've got this big metal antenna, the chassis, and it would probably make a very nice antenna, and you'd have lots of things happening, and they'd be getting into the radio and making for a not so great experience listening to it. So this capacitor's there basically to eliminate noise. So the fact that this thing was leakier than a sieve, while not ideal, wasn't dangerous, and maybe the radio would have worked fine, but that capacitor was horrible. It was off value. It leaked unbelievably a lot. It was just really, really bad. Because I actually checked it with my VTVM. One of the things I use a VTVM for when I'm looking at paper capacitors is, well, I wanted a way to how do I put it? I wanted to see if there's a way I could easily tell whether a capacitor was healthy enough to reuse. And I kept thinking about using the VTVM, because VTVMs, you can use them to check paper capacitors. Now, some people say I have lower standards for what makes a good capacitor than I do. And in one of my videos I talk about that. So I've actually been able to find used capacitors that test excuse me. I've been able to find used capacitors that, when tested with a VTVM, test exactly like a brand new capacitor. And I do two things. If I'm using a VTVM on something, that's test one. And if it passes test one on the VTM, my second test is to read the value of the paper cap. If the value is good and it checks resistance-wise just like a brand new capacitor, if it behaves like a new capacitor, I'm treating it as a usable capacitor. Now, I still, because I know it's an old capacitor, I try to make sure it's not in a critical part of the circuit. I will always put a brand new capacitor in the coupling capacitor spot. That just makes sense, because if that goes bad, you can terminate your power tube, and tubes aren't getting any cheaper or more, and they aren't making any more of them, so I'd rather not destroy tubes just because I'm being stupid. So I do reserve these for, shall we say, light duty use. But I've got radios that are using these, and at this point they're still working just fine. I haven't had any problems with it. So to me, I believe I can do a fairly decent life test using a VTVM and my capacitor meter. So anyway, I'm rambling on a bit. So this has been replaced. It's been actually, I've got a 0.01 in there. I didn't have a 0.1. When I order more capacitors, I might get the proper size for this. So far in playing this radio, I have not noticed anything that leads me to believe that this isn't working just fine. Granted, I haven't had it in more than one location. It stayed here in my shop, and I haven't tried it elsewhere. So, like I said, I might replace that capacitor once I order some new ones. Unfortunately, it was out. So, anyway, where was I headed? Oh, let me see. Oh, yeah, so I was looking at that. My mind has wandered afar. Okay. So we are going to come back out. So over here, this, maybe I'll zoom in a little bit there and angle it a little bit more so you can see more. This was fun. This was, no, this was not fun. This thing was a pain in the rear. Let's see if I can slide this in and get a better look at it. Okay. Yeah. So, there's a capacitor hiding behind here. The wire goes around behind, under everything, goes over here. Of course, I've got this capacitor, and I've got these this resistor that had to be replaced. I have all these, these two capacitors here. I've got this resistor. Basically, except for the wiring, I took everything off from this socket, including this guy right here. I disconnected him and moved him out of the way, and to get at the pins so I could replace the components I needed to replace. So this was definitely a bit of a challenge. This is where it's not fun when you're working with some of these small or more compact chassis. This skinny, narrow chassis where they stuff everything in a corner like that doesn't make for a lot of fun. But I got through it. I didn't melt anything I didn't want to melt. It came out okay. But it was a royal pain in the butt. Okay, I've got the radio connected and it's working. But we have a problem, and I can't turn this up very, very long, and I don't want to go too loud with it because, well, you guys are going to have too much or too high an audio on your headphones. We have a distortion. That's not good. So we have a problem. So, and it's volume dependent. So here's the volume control. Now I can approach it from this direction and trace it here, or I could try go from here to here. Now, probably, my first thought, well, suppose there is some kind of distortion that's happening here and it's just getting amplified here. Well, as I think about it, if that's the case, I will see the distortion right here on the grid of this tube. So if I work my way in this way, using the audio portion of my signal tracer, well, in fact, I'm going to start right here with this tube. If I start here, if I go here and I have distortion, and I go here and I don't have distortion, then I know this tube is my culprit. Now, I've checked things out fairly thoroughly already on this tube because of other things I've run into, like, the plate voltage is off, according to this anyway. Alright, so I'm going to check here on this tube, pin 2, and then I'm going to check here and see if it's clean. And depending on the results of that, and then I have to decide what to do, because I've tested all these tubes in my triplet tube tester, and they all tested fine. But the problem with the triplet tube tester is that it is an emissions tester, and those are notorious for not giving you real accurate results. And I have a Jackson dynamic tube tester, and I'm wondering if it's working right or not. So probably what I'm going to do is I'll check that out. If I discover that the problem is here, my first suspect is this tube, because I think everything else is fine here. So that would lead me to believe this tube is bad. If it tests out, this is good, that's bad. Or this is not distorted, this is. And so we're probably going to retest this tube using the Jackson once I'm sure that it's working right. And we'll see. Okay, I decided to show you what I'm doing. One of the things I did find out, before I get that far, I set this up, oops, I want that in there. I set this up, this is across the voice coil, so I can keep from ruining the voice coil, doing bad things to it. And this isn't a lot of current flowing here, but it's always a good idea to protect it. I've got it wired up so that when I want the speaker, I could hook this up, and because I got a fairly high volume. So I'm not going to do that because it'd be really noisy. So right now this is across my voice coil, so I can actually listen to just my signal tracer. I don't have to listen to two speakers at the same time, which would not be good. All right, so here's pin 6, which is pin 6, which is right here, which is the grid. Oops. Here's our grid right there, pin 6. And when we look at pin 6, then nice and clean. Now I got to reduce the amplification on my machine, and I think you can tell the difference. That son of a gun is really misbehaving badly. So that tube I think is probably bad. I'm going to check it out, and I'm pretty sure the end result is going to be that it's not healthy. So this is an example. Now, well, I'll actually say more when I come back and I've confirmed everything. But here's the other thing I wanted to mention. I keep losing track of what I want to say. This is terrible. All right. Let me show you what I did. The last part of that I wanted to last thing I wanted to show you on this whole section here was, and I forgot to do that, was I've got I have this little solid state rectifier in here now. And by the way, you notice the tube is, I put the tube back in. Tubes without filaments are just envelopes full of vacuum. They don't do anything. So it's not a problem to put the tube back in the socket, and I threw that back in so that, you know, just for appearance sake, if somebody opens the rear panel, they're not going to see a radio missing a tube. Now when I go to sell this, I'm going to I'll make it part of the description of the radio that the rectifier tube is bad. There's been a solid state rectifier installed. If they want to get the tube for this and remove this, which would be very easy to do, they need to change. They also need to change the resistor that is in this set, because this was 140 ohms, the resistor that went from here to here, and then fed into the rest of the power supply chain. Because these silicone diodes have a much lower internal resistance than a rectifier tube or a selenium rectifier, the voltage that goes into the set is going to be higher using one of these. And when you're dealing with a set like this, any set, you can damage the filaments by running them too hot, and you can also run the plates too hot, which is also not good. But these low voltage tubes, the filaments are kind of fragile, and you really don't want to run them too high. So when you make this kind of a change, you have to up the resistance. The original resistor won't work. In my case, mine got fried in half, so it really wasn't going to work. So at this point, I have a 180 ohm resistor in here, and it's on top, and I'll show you that shortly. And that worked out perfectly. I just happened to have a 180 high wattage resistor, and between this thing right here and that, which is anchored to the chassis with this screw, nut and screw here, this chassis gets kind of warm. It's surprising how warm it does get. Probably most of it's coming from that rascal right there. But anyway, I digress. So I have checked to see if the voltages are correct. And one thing I ran into is that the voltage at the beginning of the chain, which is supposed to be 110, is like 117 thereabouts. But what's interesting is this tube, which is supposed to be 2.5 volts on the filament, is 2.5 volts. The other tubes are supposed to be 1.4 volts. Some of them are 1.3, some 1.6. So they're pretty close to what they're supposed to be. So I'm thinking that 180 is a decent choice. I could opt for even more resistance. I just don't know that I need to do that. I don't know that this is going to be played a huge amount, although if you're in an environment where you can get AM better than I can here, this radio does sound pretty decent, and you might find yourself using this more than you might normally with another radio. There's also one other thing I need to mention. When I was hooking up the my Conair, I had it attached to the chassis first. The radio did not like that, especially when I was connecting to this. That connection there, it really hummed and got really unhappy. I had to connect this to the common return, the B minus, and that made it a whole lot happier. And you could hear how nice and clean it was on the good side, and not so clean on that side. So, I will be back. Okay, I'm back. So if I put this on here, and sounds good, right? So I have to change this because we're amplifying more. Go there. I've got this volume control almost maxed. This is the only station I can really use that will reproduce this problem. It's a local station, so I've got this much better reception and it's got more power. So you can see I put a new tube in, and you can see that things are a whole lot better. And the other thing I wanted to check out was, remember I've been saying that the plate voltage on this thing is too high, according to the circuit diagram. And so I want to see, because turns out this tube was bad. I tested it on my better tube tester, and it failed the test. It was bad. So before on this tube, I was getting 70 volts on the plate. Let's see what we have now. I have 65 volts. So this better tube is conducting more, and it's dropped the plate voltage down slightly, 5 volts. That's the difference. That tells me two things. That yeah, indeed, there's no question about the other tube being bad. Well, obvious, because now the distortion is gone. The volume for a given setting of the volume control is better, a lot better. And of course the distortion is a lot lower. If you max this thing out, it still doesn't like being maxed out, but if you were to do that through the speaker, you wouldn't like it being that loud. It definitely puts out much more than it did before, and like I said, you probably wouldn't like it too much. So the other thing I wanted to show you is what I did with that resistor, how I mounted it, and all that. Let's see, we'll get this out of here. For whatever reason, the reception around here really sucks. And for some reason today, it sucks worse than usual. One of the high-powered stations, WGY, is not coming through as well as it might. I might double-check the alignment on this before I call this radio done. There are some things I want to check out. But anyway, so here's my resistor. This is a nice Arcol 180 ohm resistor, and mounting this to the chassis definitely makes a big difference in the temperature of this thing. Of course, what's nice about putting the old tube back in, number one, makes no impact whatsoever on the on what happens to the power supply voltage. It just basically the radio ignores the tube because the tube isn't doing anything. Let's see, there was something else I was going to mention and I can't remember what it was. I don't know. Okay, I may one of these days make myself a switch that will guarantee that I do this right. Because it'd be really easy, because the way I've got this set up is, if I want the speaker to work, I clip this on here, and I take this off. Now I don't have to, but I'll get a better representation of what the speaker and what the radio is actually doing if I do that, because this resistance here is going to affect it a little bit. And then when I don't want the speaker, I do that, and I do that. So, like I said, someday I might rig up a switch. I'm sure I've got something floating around I could use. Because what I did was I unsoldered one leg of the voice coil feed to the speaker so I could do this. I much prefer that. It's kinder to me, and when I'm trying to record what I'm doing, it's kinder to the volumes that you're listening to. So anyway, this is the backside of my radio, which I don't know if I showed that before or not. I'm forgetting what I did and what I didn't do. So now what I'm going to do, I'm going to finish up by doing an alignment on this. I don't think, if the reception improves dramatically by doing that, then I'll come back and I'll show you that. Otherwise, I'm going to call this a wrap, because the radio now works the way it's supposed to. So anyway, we're wrapping up here. Like I said, I will return if there's anything to show you. Otherwise, well, actually, I might put this in the case and I can show you it operating, but I'm hoping that I can improve the performance of this beyond what it is right now, because it's not really great. So we'll see. We'll see. Okay, I decided to come back and show you this together. Now, what I'm doing is oh, that's not going to work. Okay. I was disappointed with how it was behaving when I got all done putting the tube in it and all that stuff. So I went through and I touched up the alignment and I did correct a problem with it. So it's definitely working a lot better. I'm on, what is, oh, 590. I'm just going to turn it briefly because I got music on it. This is a hard station to get, very hard. But this thing, I don't know what that station is. Most of my radios can't even get it. It's up around 700. One of the things I've discovered is that if I leave my LED lighting on, which this room is entirely lighted with LED lighting, my radios don't like it much.
This business.
This is
But
810.
one of the first things, any
810 WGY, modern radios that are decent will get that. Used to be a blowtorch station that pretty much any radio would get, but I think they've been forced to reduce their power. But anyway, another station there. This is 2 o'clock in the afternoon. There's another station there. At night, this thing picks up like you can't believe. And this thing gets stations all over the place. So in a better market where there's stations that more stations and stations that are higher power than we seem to have in our area, this radio would be an amazing performer, and it sounds really good. I wish I could play more of the music, but that's as much, and it's probably maybe too much. They're probably going to ding me for that. I hope not. So there it is. It's done. It's working. It's working as well as you could expect. However old this, I think this is 1947, 6, somewhere around there. I mean, it's late 40s. I know that. So you've got this old AM radio, and it sounds really nice. Now that I fixed that new tube made a huge difference in the volume this thing has. The sound quality improved. On a decent station, unlike that one which has a lot of hum in it, you can get a nice bottom end response. I'm pretty happy with the outcome, with how this thing turned out. So I'm going to wrap this up here, and hopefully see you in the next video, because I'm going to be working on a little Motorola suitcase radio. That's what it looks like. The person I bought it from thought it was a small bowling ball bag. That would have to be a pretty small bowling ball, but in any case, you'll see when I put that one on the bench what it looks like. So, enough for now, and hopefully see you back for the next video.